Okay, so we're going to get into section 2 and talk about solving linear equations. We're going to be doing just a lot of like solving one-step equations and a little bit of the two-step equations. So a linear equation would be like an equation of a line. Okay, so straight lines. Most of the time you see things like y equals mx plus b would be a straight line. That's your basic slope-intercept form. Now we're not graphing, we're just talking about solving equations. So the kind of the beginning of this is solving like a one-step equation. So you're either adding, subtracting, multiplying, or dividing. We got to talk about the basic principle of equality, which basically says whatever you do to one side of the equation, you have to do to the other side in order to keep it balanced. And you've probably been taught that and told that since algebra when you were solving equations. If you subtract from this side of the equal sign, you have to subtract from the other side of the equal sign. If you forget to do that, it leaves it unbalanced and it causes the equation to end up giving you the wrong answer. So you want to make sure that you're doing that. So then we have what's called, like, they call it the addition axiom. Basically for you guys, it's adding or subtracting. So like if you're solving an equation and you have to add or subtract something over, that's all that you're doing here. So to get started, some of these are going to be really basic. If I have x plus 4 equals 8, in order to solve, I would subtract the 4 from both sides, and I would have x equals 4. Okay, what would you guys do for number 2? Subtract 3, and so what's 8 minus 3? 5. So we would get x equals 5. Okay, so that would be subtracting. We also can do this by adding. So number 3 starts at x minus 2 equals 4. So we add 2. So 4 plus 2 is going to be 6. So we get x equals 6. Okay, I want you guys to take a second, look at numbers 4 and 5 there on that first page, and solve them. So what do you do for number 4? Subtract the 5. So what is 2 minus 5? Negative 3. This one was written a little bit differently because they put the x second. So if you needed to, you could have always kind of flipped these around so that it said x plus 5 equals 2. So you can rewrite that equation if that makes more sense to you as to why we subtracted 5. We subtracted 5 though because it was positive. So you always just want to do the opposite of whatever it looks like. What did you do for number 5? Add 1. So it says 11 equals x, which is the same thing if you flip it around and you say x equals 11. So you can go either way there. So that's using the addition one. It kind of also included the subtraction one in those problems. Now we're going to move on the next page to using multiplication, and this is also going to include the division property too. So again, if you multiply or divide on the left side of the equation, you have to multiply or divide on the right side of the equation. That doesn't change at all. So getting into some of these. The first one you have says 4x equals 48. So 4, when it sits next to the x like that, they're actually being multiplied. It's 4 times x. So the opposite of that multiplication would be to do division. So we're going to divide both sides by a 4. Anybody know what 48 divided by 4 is? Good, 12. So x would be 12. Now number 2, you have a decimal. It's 0.5 times x. We still solve it the same way. We're going to divide both sides by 0.5. So 45 divided by 0.5 is like the same thing as 45 times 2. So what would that be? 9. Now, if they give you a fraction, like number 3, we have 1/4, and then times n equals 7. Instead of trying to divide by a fraction, because sometimes that can get messy and complicated, we have what's called the reciprocal. Reciprocals are when you take your fraction, you flip it upside down. So what I'm going to do is, instead of dividing by 1/4, I'm going to multiply both sides by 4. This way, the 4 and the 1/4 cancel, and I'm left with n, because 4 times a 4th is a big 1, because the 4's cancel each other out, basically. So I'm left with n, and then 7 times 4 is going to be 28. If you have a calculator, you can divide by a 4th. You could take 28 and divide it, or you could take 7 and divide by 1/4. Your calculator will know how to operate with that. But if you want to make it easier on yourself, multiply by the reciprocal, because then you don't have to worry about that fraction at all. Now, number 4, the only thing that's wrong with this one is you've got a negative sitting in front of the letter. We always like our letters to be positive, okay? We don't want things to be negative. So what we're going to do is get rid of it, and I'm just going to divide both sides by -1, because that's going to make n become positive. It just switches the sign. What that does then to 25 is it makes it become -25. So it just switches the signs on both sides. So always make sure that your letters are positive. If you've got that negative in front, just switch the signs of everything to get it to switch. Now, if you wanted to, you could always verify, or you could check the solution of an equation. So especially if you had like a more complicated equation and you wanted to make sure that you did it right, you can take the number that you found for your variable and plug it back into your equation and simplify and make sure that it does balance out, that you get 5 equals 5 or -6 equals -6. So that's all you need to do, is just substitute that value that you found in, make sure that it's balanced, and if it does, then you know you did it right. If you don't get it to balance, if you get like 10 and -2, then you did something wrong. Either you plugged it in wrong, or you did something wrong with your math when you went to solve it. Okay, we're going to get into some more problems that are not harder, but just a little bit more complicated. They've got more to them. Okay, so we're first going to talk about solving linear equations that have like terms on the same side of the equation. So if you've got something that has a bunch of x's and they're not all simplified down to one term, you need to do that first. So if you see a 5x and a 3x and a -2x, you need to combine those first before you try to solve the equation. Same with like numbers. If you have a bunch of numbers that are kind of added or subtracted, you want to combine those first and then try to solve it. So for this one, I've got 4x minus x equals 7 plus 8. So remember, if it's just an x by itself, there's technically a 1 sitting in front. So it's 4 minus 1, which would be 3. So this would be 3x equals 7 plus 8 is going to be 15. So I'm simplifying this now, so it says 3x equals 15. How would you guys solve for x now? Divide both sides by 3. So we get x equals 5. The next thing here is when we've got like a two-step equation. So they've got those same like terms, but they're on opposite sides of the equal sign. So before, we had our x's on the left side, our numbers on the right side. We kind of simplified first and then solved. In this one, you've got like numbers on either side of the equal sign. So you have to get those combined first before you try to get the term with the letter by itself. This is known as a two-step equation. So you have to add or subtract a number first and then multiply or divide if you need to do that to get that letter all alone. This is kind of combining some of the stuff that we've been doing separately. Like earlier, we were doing just one-step equations by just adding or subtracting, just multiplying or dividing. This is starting to combine those. So we have 2x plus 4 equals 8. So the first thing I'm going to do is subtract 4. You always want to move plain numbers first. So now it says 2x, and then 8 minus 4 is 4. So we have 2x equals 4. And then I'm going to divide both sides by 2. So 4 divided by 2 is going to be 2. Okay, you guys try to do number 2. In this case, you've got a negative 4x and an 8x that need to get combined. What I would have done is added 4x over to the 8x. So what's 8x plus 4x? So we've got 9 equals 12x. How do you get the x over? So when I divide by 12, I have x equals 9 over 12. What's a number that can go into both 9 and 12? 3. So I'm going to take out a 3. I'm going to divide the 9 by 3 and the 12 by 3. And this would get me 3 over 4. So that would be my value for x, 3/4. Make sure if you've got fractions like that, that you do simplify. Don't leave it as 9 over 12. Take out any common factors that you have. Okay, I want to show you guys a couple of special cases here. So for number 3, on the left side, there's really not a lot for me to do. It just says 4x minus 3, so I'm just going to leave this alone. On the right side, though, I have a 3x and I have an x. So those are like terms that I need to combine. So I'm adding 3x and 1x. And there's a 1 there, so that's 4x. And then I still have minus 3. What do you guys notice there? They're the same on both sides, right? You've got 4x minus 3 equals 4x minus 3. So what happens here is if I try to start combining things, so if I try to add 3 over or subtract 4x over, they all cancel out and I end up with a statement that says 0 equals 0, which is true. 0 is equal to itself 0. So this is a special case where you get infinite solutions. Remember that word infinite is like infinity, which means it goes on forever. So infinite solutions means any number would work. I could put in anything for x. I could put in a 2, a 20, 200, negative 2, negative 20, negative 200, anything I wanted to, and it's going to end up balancing out. So it's infinite solutions. Number 4 is also a special case. If I look at this one, again, I don't have to do anything to the left side. It's just going to say 3x minus 7. But on the right side, again, I got to combine. I've got an x and a 2x. So what's x plus 2x? 3x. So I've got 3x minus 11. What's going to happen on this one? What's the same on both sides for this one? The 3x. So if I try to subtract 3x, let's just see what happens here. They're gone on both sides because it's 3x minus 3x, which is a 0. But this time I have negative 7 equals negative 11. Is that true or false? That's false. Those two numbers are not the same. Negative 7 is not the same thing as negative 11. Okay, so these are not equal to each other. This would be the situation then where there's no solution. Okay, I can't solve this one. That means that no matter what x I put in, it's never going to work. It's never going to be balanced. Something happened when these equations were created that they're never going to equal each other. Okay, so if you get the exact same equation on the left side as you get on the right side, that's infinite solutions. If they don't match, that's no solution. So a lot of times the x term will cancel, but you're left with numbers, and that will not give you a true statement, like you saw here. Okay, so why don't you guys take a look and do 5 and do 6. I'll give you a couple minutes to work on those two. Solve both of them. Okay, so for number 5, you got to move a couple of things here. You have to move the 6x over, so I'm subtracting it from the 9x. So 9x minus 6x would be 3x, plus 2 is left. On the right side of the equal sign now, you just have a negative 10, because the 6x's were moved. Now I'm going to subtract 2 to get my numbers on the same side. So I'm left with 3x equals negative 10 minus 2 is going to be negative 12. Last step here is divide by 3. So what did you get for a final answer? Good. X equals negative 4. The last one is similar. Make sure that before you try to start moving things around, on the left side, there's 2 separate x terms here. I would combine those first. So you've got 2x plus 5x, which would be 7x, and then you have that minus 3, equals 8 minus 6x. So now we got to get our x terms together, get our numbers together. If I can, I like to try to keep things positive, because positive numbers are easier to work with than negatives. So I'm going to add 6x to the 7x. So this would be 13x, and then you have minus 3 equals 8. Then I'm going to add 3 over. And so I have 13x. 8 plus 3 is going to be 11. Last step is divide by 13, and we're not going to be able to do a whole lot with this, because 11 and 13 are both prime numbers. So we're going to leave it as just 11 over 13. If you happen to give me the decimal answer instead of the fraction, as long as it's the correct decimal, I'm going to give you credit for that. Okay? But if you write down the wrong decimal, or you don't get the right fraction or whatever, you will miss a point. So just make sure that you're being careful. But I'm not super picky about whether you give me fractions or decimals for final answers. Okay, the last thing that they want us to cover in this section is taking care of equations that involve parentheses. So we've talked in the past about order of operations, how you want to make sure that you take care of those parentheses or any grouping symbols first. And you can do that by either evaluating what's on the inside, or if you can't combine what's on the inside of the parentheses, then you may have to use your distributive property in order to get it to a point where you can simplify. So apply the distributive property to remove the parentheses from the equation, combine any like terms that you have like we've been doing, get your letter term, like usually to the left side of the equation, and then your number term on the right side, so that then you can finish out by either multiplying or dividing. So for the first one, it says 28 equals 7x minus 3 times x minus 4. So I'm going to distribute. Now be careful with these ones because you've got negatives involved. Big mistake that I would see, or a common mistake I should say, is that students will forget that negative and it throws off the entire answer. So we've got 28 equals 7x. Now you're taking negative 3 times x, so that would be negative 3x, and then negative 3 times a negative 4, which is 12. I'm going to subtract 12 from 28. I'm also going to combine my x's there, because I've got 7x minus 3x. So 28 minus 12 is 16. If I combine 7x minus that 3x, I get 4x. Then divide by 4, I get x equals 4 for this problem. Okay, so you guys take a minute and do number 2. Watch your signs on that one as well. So when you distribute that negative in there, it says 6 minus x minus 3. So there's like a negative 1 is being distributed to the parentheses. So what I'm going to do is add my x over to the 2x. This is a little bit backwards because normally we like the letter to be on the left side. But this will still work. Now I'm going to combine my 6 minus 3 and get a 3 here. 2x plus x is going to be 3x. So the last thing is to divide by 3 and we get x equals 1. So a couple times in like the real world when we see problems that involve parentheses would be perimeter. Perimeter uses parentheses a lot, especially for rectangles, because you've got like length and a width. And instead of doing length plus width, we can do 2 times the length plus the width. So that's when you might see parentheses show up in a problem involving perimeter of a shape. So this first one says that a horticulturist marks off a 32-meter wide rectangular nursery plot with 158 meters of fencing. Because the plants must be properly spaced, she needs to know the length of the plot. Find the length in meters. So for perimeter of a rectangle, we can take 2 times the length plus the width. Now, the 158 meters, that's the perimeter. That's how much she used to go around this rectangular space. So we're going to put 158 in for the P. 2. Now, we're trying to figure out the length, so we don't know what L is. So I'm going to leave L as the letter. 32 is talking about how wide it is, so that's your W. So we're going to do plus 32. So using like what we just did, we can use our distributive property here. We can take 2 times the length, 2 times that 32. So now it says 158 equals 2L plus 64. Now it looks like an equation like we saw before. We just don't have an x. We have an L that we're solving for. So I'm going to start by subtracting 64. So 158 minus 64 leaves me with 94 equals 2L. So I divide by 2. I'm going to bring this over here because I'm running out of space. My length then is going to be 47, and that would be meters. So a good way to check that is to take 47 plus the 32, multiply by 2 to make sure that you get that 158. Make sure that it works out with our perimeter equation. Last one here. A machine part weighs 2.7 kilograms and is to be shipped in a carton weighing X kilograms. If the total weight of 3 packaged machine parts is 9.3 kilograms, how much does each carton weigh? So to figure this out, you're taking the part weight plus the box weight to get the total. And we're doing this 3 times because we're doing 3 of these parts that they're shipping out in 3 separate boxes. So I'm going to take 3 for the 3 packages times the weight of the part, which is 2.7, plus the weight of the carton, which they said is X. And this gives me a total of 9.3. So I have a question for you guys. Instead of distributing 3, could I do something else instead to get rid of it? What? I could divide both sides by 3, because right now it's like 3 times that quantity, so you could still use your distributive property. Or if you want to avoid that, you can actually divide both sides here by a 3. And you have 2.7 plus X. That kind of eliminates the 3's, like these cancel. And then 9.3 divided by 3 is going to be 3.1. What's the last thing we would have to do? Minus 2.7. And that's going to give us 0.4. And that would be kilograms. So each carton weighs 0.4 kilograms. So that's just kind of an alternative to solving that one without using the distributive property. The opposite of that would be to divide, and that is available for you to use if you wanted to.